table shows information about the number of hours that 100 children used a computer last week. So we've got eight children used a computer between 0 and 3 hours. 16 children used a computer between 3 and 6 hours. 21 children used a computer between 6 and 9 hours. And 36 children used a computer between 9 and 12 hours, and so on. It's important to notice the inequality symbol here, which means that none of these 8 pupils used a computer for 0 hours. They used it for more than 0 hours, and up to and including 3 hours. So it's more than 0 hours and right up to 3 hours. These 16 pupils used the computer more than 3 hours and up to and including 6 hours. It's important to notice that 6 hours is included here, but it's not included here. We're asked to work out an estimate for the mean number of hours that the children used a computer for last week. Now, the mean is normally the sum of all the hours divided by the sum of children. So normally we would have total hours divided by total number of children. Okay, so if there was 8 children here and 16 children here and 21 children here and 36 children here, 12 children here and 7 children here, we need the total number of children. So in some work you would have heard or used the expression sum of f. F is your frequency. And the sum of f is the sum of this column. And the sum of f is, in this case, the total number of children. So the total number of children is the sum of f. So what is the total number of children? The total number of children is 8 plus 16 plus 21 plus 36 plus 12 plus 7. There is 100 children in total. Okay, so we have 100 children. So that means that I'm going to have a number and I'm going to divide it by 100 to get the mean number of hours. Now there's a problem. The problem is this. 8 children played their computer between 0 and 3 hours. So we don't know the total number of hours played on the computer by those 8 children. So we have to pretend that we know how many hours each of these 8 children spent on the computer. They could have spent anywhere between 0 and 3 hours on the computer. So what we do is we pretend that we know that all of the children spent an amount of time on the computer. And the amount of time that we pick is known as the midpoint between the 0 and the 3. So there's 0 and there's 3. So we're going to pretend that each child played or worked on the computer for 1.5 hours. Likewise, we don't know how many hours each of the 16 children spent on the computer. So we're going to pretend that each of the 16 children spent halfway between 3 and 6 hours on the computer, which is 4.5. Similarly, for the 21 children, we will pretend that they spent halfway between 6 and 9 hours, which is 7.5. As for the 36 kids, we'll pretend that they have spent 10.5 hours on the computer this week each, and these 12 children will have spent 13.5 hours on the computers this week, and each of the 7 children will have spent 16.5 hours on the computer this week. Now, some people get a little confused about how you choose this middle number. So, the simplest way to make sure that you've picked the right mid-value is that you pick up your first number and the second number, you add them together and you divide by 2. And that should get you 1.5. Let's write that out neatly. 1.5. Similarly, to work out the midpoint between 3 and 6 hours, you get your 3, you add on your 6, and you divide by 2. 3 plus 6 is 9. 9 divided by 2 is 4.5. That is how you work out each of your mid-values. Now, we are asked to work out an estimate for the mean. The mean is the total number of hours spent on the computer divided by the number of children there is. We have already established that there are 100 children. Now we have to make sure that we know the total amount of hours spent on the computer. Eight children have spent about 1.5 hours each on the computer. 16 children have spent about 4.5 hours each on the computer, and so on. We want the total hours spent on the computer. So if I get my 8 children and I multiply by 1.5, that will tell me how many hours those 8 children spent on the computer. I will then have to add on the 16 times 4.5 because 16 children spent 4.5 hours on the computer. Likewise, I have to add on 21 times 7.5 and 36 times 10.5 and 12 times 13.5 and 7 times 16.5. And all of those products added together will give me the total number of hours spent on the computer. To do this, it is often very useful to write out a new column on the table, whereby you get your f value and you multiply by x, and that there is then called your fx column. And okay, so fx for column 1, for row 1 will be 8 times the 1.5, this here part here. 8 times 1.5 is 12. Then 16 times 4.5 is 72. Then 21 times 7.5 is 157.5. Each of the 36 kids spent 10.5 hours in the computer. It gives you 378 hours. Each of the 12 children spent 13.5 hours in the computer, given 162 hours. And finally, each of the 7 children spent 16.5 hours each in the computer, giving 115.5 hours. Now, if I total up all of these values, that will tell me the total number of hours spent on the computer. And some of you will recognize the term sum of fx, and then I can fill it in here so you recognize that the total hours is the sum of fx, and the total number of children is the sum of f. The total number of children is the frequency column summed, which is 100, and now we're going to find the sum of fx. 12 plus 72 plus 157.5 plus 378 plus 162 plus 115.5 gives 897. So I'll just check that again to make sure. Be ashamed to do all the work and then a simple slip error would lose you a mark. 897. So to get the answer for the mean, I get 897 divided by 100, and each child spends 8.97 hours on the computer each. And that is an estimate for the mean because we had to use the mid values. We had to pretend that each of these 8 children spent 1.5 hours on the computer, even though it might have been anywhere from between 0 hours up to 3 hours, and so on. So, a quick summary on how to do this question. The sum of the frequency is sum of f. To get the total number of hours, we had to get a mid value for each of the rows, multiply the mid value with the frequency value for each of the rows, add up the products of fx to get sum of fx, and the mean is equal to sum of fx divided by the sum of f. The sum of fx was 897, the sum of f was 100, so the mean number of hours, which is sometimes written as x bar, is 8.97 hours.